In this video, I'm going to go through about half of the problems in the 1.1e lesson, solving linear inequalities. Be sure to do all the problems, show all your work, graph any of the ones that require graphing. You can either do this on your own or with the assistance of the key on Blackboard. Be sure to check your answers, though, with the key to make sure that you're doing them right. We're going to start with the first two problems, and then I might skip around and do a different type of problem so you see a variety. Let's start with number one. Remember that from last year, any strategy that you used for solving an equation can be used for solving an inequality. We're going to distribute the 5 through if we choose to fraction bust. You don't have to do this, but let's say we want to do that. We get 5a minus 7 is greater than negative 45. We'll use the additive inverse to add 7 to both sides. We get 5a is greater than negative 38. And we use the multiplicative inverse to multiply both sides by 1/5 or divide by 5. And we get a is greater than negative 38 over 5, or we could write it as a is greater than negative 7 3/5. Since we're going to graph, the mixed number might be easier. You want to make sure when you're solving these that your variable is on the left side for your final answer. That's required. It also helps with graphing. There's a little trick. Got to flip-flop this because I'm to the left of 0. This is negative 7 2/5, negative 7 1/5. There we go. Okay. And whenever we graph these, we either did an open or closed circle. Since this does not include the endpoint of negative 7 3/5, it's an open circle. And we want values greater than that, so we're going to go to the right. And one of the tricks was that the inequality almost hinted at the direction that you should be shading. Let's look at number 2. So one of the things you might recall is that for the most part, these were the same as equations, but there was one catch, which is that when you get to removing the coefficient of the variable, which is usually in the last step, if you divide both sides by a negative or multiply by negative 1/6, then you need to flip the direction that the inequality sign is facing. And so actually the solution for this one is t is less than or equal to negative 11. If you remember from equations, a lot of times we got one answer, like x equals or t equals. In this case, we're getting lots of answers, anything in the shaded region. And remember that we also need to fill in the endpoint this time because negative 11 would work as a solution because negative 11 is less than or equal to negative 11. Let's skip down and look at a different type of problem, number 5. I'm not going to fraction bust because I'm kind of noticing that this might fraction bust itself. 2 minus x plus x greater than negative 15 plus 7. All right, so we're back to what we saw with equations, which is sometimes the variables cancel. If we get a true statement, 2 is greater than negative 8, then that means we have infinitely many solutions. So actually the same rules apply. We still need to graph it. So this time we can pick anything. We're going to shade the whole number line. Whereas in the previous ones, both problems, there was lots of things that worked, but if you picked negative 9 for problem number 2, that would not check out if you were to plug it back into the original inequality. Let's skip down to number 7. On 7, again, we'll go with our fraction busting strategy. We're going to distribute once, twice, 3 times. We end up getting 7n plus 2 minus 7 is less than or equal to 14 times the 7th is 2 times 5 is 10. In this one, we don't flip the direction that the inequality faces, 2 and 1/7. I usually put this number in the middle. You don't have to. Okay. And this is a closed circle because it has the part equal sign there. And we're going to shade to the left. Remember this little trick, the arrow essentially tells you you're going to shade to the left. Number 8, and then we'll go to some word problems. Let's distribute. Get 3 plus 9t minus 12t minus 8 plus 3t is greater than 7. I'll start combining like terms. I get 3 minus 3t minus 8 plus 3t is greater than 7. And I'm noticing my t's are going to cancel. I'm going to get negative 5 is greater than 7, which that is not true, it's false. And so here was the other special case, that if we get a false statement, that means that absolutely nothing's going to work. Regardless of what we plug into the original inequality, it's not going to check out. So we'll leave the number line blank. And then with word problems, similar thing happens, but we sometimes need to make a decision about our final answer, which is maybe different than the problems that we just went through. So number 9 says you and your family want to rent a limousine for your graduation party. The limo costs $6.50 for the evening and $1.30 per mile. If you want to spend at most $700, that's critical. That will help us decide which inequality sign to use. How many miles can you travel in the limo? Round your answer to the nearest mile. So I'm going to have x equal the number of miles. And it sounds like there's a flat fee of $6.50. There's a constant plus 1.3x, so $1.30 per mile. At most, meaning it can be 700. It can be equal, but it can't be more. So less than or equal to is the inequality sign I'm going to choose on that one. Okay, once you have it set up, we repeat the process from the previous page. I'll multiply this fraction by 10 to get 500 over 13, which is x is less than or equal to, if I change that to a mixed number, it comes out to be 38 and 6/13. And it gave us the restriction that we only can pay for whole miles. And so it looks like the largest whole number that would work for this inequality would be 38. 37 would also work if I didn't want to go the farthest distance possible. So I'm going to say, therefore, my family and I can travel at most 38 miles, which allows us or leaves it open to the fact that we could choose to, for one reason or another, only travel 37 or 36. I'm going to skip down because some of these are very similar. Let's look at number 11. You did consecutive integer problems last year. We have 2 consecutive odd integers on this one. And so we always chose for our first one, first odd integer, chose x or n. The second odd integer was x plus 2. And that was because if we chose, or we found out that x was 11, the next odd integer would be 13, and we see that there is an increase of 2. So that's why we do x plus 2, which is weird because it's an even number, but that's how odd numbers operate. So our equation will be x plus 2 at most, so less than or equal to 123. It can be equal. So this is what I was saying when we started these word problems, is that you sometimes have to make a decision about what your answer is for your sentence. So I have x is less than or equal to 60 1/2, and I'm looking for odd integers. So 60 doesn't work, but 59 does. So therefore, the two odd integers are 59 and 61. Because this one, x would be 59 plus 2 would get me to the next odd integer, which would be 61. And 59 plus 61 would be less than 123. It did say to identify the greatest, find the pair with the greatest sum. So that would be the greatest pair. 57 and 59 would not be the greatest pair, although it would be less than 123. Let's look at the last one. We might only do the setup on this one. The longest side of a triangle is 3 times the shortest. Third side is 4 inches longer than the shortest. How long is the shortest side if the perimeter is more than 39 inches? So I have a longest side, the shortest side, and I'm going to call it the third side because I don't necessarily know how it compares in length. Or maybe I have an idea, but maybe once I have numbers, I'll have an idea of how these sides compare. So I've got 3x, I've got x, and I have my third side, which is 4 inches longer, x plus 4. So maybe that one's the middle length. I guess it might be based on what x is. It might change. So my perimeter is sum up all the sides. That's my formula. And it's greater than 39 with no equal sign. Okay. And the question said, how long is the shortest side if the perimeter is more than 39? And so, therefore, the shortest side is more than 7, and we're dealing with inches. So I don't know if it's 7.1 or 7.01 or 8, but it's definitely more than 7 inches. Make sure to go back to the other problems, check them with the key. If you need a lot of help, please use the key to fill them out. Bring questions to the next class.